Well, welcome once again, AB Calculus students. Let's go ahead and let's get ready to look at how to score your questions 1 through 3 on the 2019 AP test. So interestingly enough, I was actually part of the reading team this last year. So unfortunately for you guys, I guess, well, maybe sort of unfortunately, I scored mostly BC questions. So there's only one question on this test that I actually scored, but I had my roommate scored all AB questions. So I did get to ask him about a number of these, and he gave me quite a bit of insight into them. So first question we see is our classic rate in, rate out kind of problem. We have a rate fisher coming into the lake. That's enter. That's our E equation. We have a rate fish R leaving the lake. That's our L leave equation. So let's look at how we're going to score this. So first for part A, it's 1 point for getting your integral. Now you can actually write out the integral. You don't have to list it as E of t dt because you are going to have to write it out when you enter your calculator. But you must list 0 to 5 of that function. Okay, in the integral form, if you just have the answer, you're not going to get the integral point. We expect to see what you actually put down. If you did not round to the nearest whole number, that's okay. We still took the answer. Basically, just looked at this. So long as it said 153, we didn't care what the decimal was after it. You got point there. Okay, part B. Part B, once again, you get 1 point for the integral. So knowing you had to go from 0 to 5 to this L of t dt. Your answer point included knowing that you must actually divide by 5 or multiply by 1/5 and then getting the correct answer. For part C, there's a couple ways you could have done part C. So we'll talk about the first way first. The first way to do it is to understand that you must look at the two rates. And so if you either look for where the difference between the two rates is 0, or you look for where the entry and the exit rate are equal, either way gets you a point. Then if you go ahead and calculate the time when that happens at 6.204, you get a second point. And then if you justify that that is the point where there is the greatest number of fish in the lake, because the derivative or the rate that the rate of change of fish in the lake here is positive up until this time, and then the rate of change for the fish in the lake is negative after that time. Therefore, you can argue that. That's one possible way you could justify it. You'd have to explain that. The difference there between those, which is the rate of change of the fish in the lake, is positive, and then it changes to negative. So that's one way to do it. The other way to do it is to use the candidates test. So once again, as far as the candidates test, this would be a way of doing essentially getting the third part. So this is what it would look like using the candidates test. So it's still 1 point for understanding that we're looking for finding that t value there, which in this case is we list as this constant. But if we know that the max must be at either an endpoint, a critical point, or an endpoint. So if you find the value at all three, we see that that's the max. That is your justification there. Using the candidates test also works, and that requires the integration there, but you can go ahead and do that using candidates test. Okay. Part D is worth 2 points. So the first point's a very soft one. If you understand, you must look at the derivative of E at 5 and the derivative of L at 5. You get a point. Pretty straightforward. This is the part where you have to be careful, because when you are explaining this, you must explain that it's the rate of change in the number of fish is decreasing. It's not that the number of fish is decreasing, because this gives you the rate of change of the rate of change. So you could say that the rate of change in the fish is negative. That would also work. That could also be a way of expressing it. But it's basically the easiest way to say it is it's the rate of change in the number of fish is decreasing at the time t equal to 5. So you have to be careful and make sure it's the rate that you say is decreasing, not the number of fish that are decreasing. Okay, go ahead, score that out of 9. And let's move on to question number 2. So question number 2, you will score in the according fashion. Once again, we've got a few alternate ways that students can do these things. For part A, there is a way to tackle it using the mean value theorem. There's also a way to tackle it using the extreme value theorem. And you could do either way. So if you use the mean value theorem, it's 2 points for part A regardless, but if you use the mean value theorem, this is what you would need to have. You would first need to have that this v sub p of 2.8 minus v sub p of 0.3 equals 0. Or in other words, these two things are equal. That would be another way of saying it. And since those two things are equal, we get that our average rate of change is 0. Therefore, by the mean value theorem, and you must say that it's continuous and differentiable in order to do this, or you could say, you don't have to say it up here, you could say it down here. You'd say because it's continuous and differentiable by the mean value theorem, there is a C such that V of P prime at that C is 0. That's using mean value theorem. The other way you could do it is using the extreme value theorem. And with the extreme value theorem, you still have to have the differentiable and continuous piece. But what you see there is the extreme value theorem is, and this is unlikely that you would have done it this way, but you could. So basically what you would have to say is that it has a minimum on that closed interval, and then you could go ahead and do your evaluation. And so essentially what you would have to figure out is that you know that this V of P here is negative, and you know that the V of P at the 1.7 is going to be equal to the V of P of 2.8. And so since it has a minimum, and because it's differentiable, then we know it must be equal to 0 at that minimum, essentially, is what it happens. Very unlikely you would have done it that way. All right, part B. Part B, you get 1 point simply for getting your answer and using a trapezoidal sum. So we need to see the trapezoidal sum. We need to see the correct answer. Really, you get your entire credit if you have this line right here. That line right there, you could leave it just like that. That gets you your entire credit. If you do simplify, you do have to get that answer. All right, for part C, 3 points. 1 point for the correct interval. That would mean that, notice this interval here is from 1.866 to 3.519. So 1 point for getting that interval. 1 point for getting the definite integral. That's going from this A to B, in other words, this value to this value of the absolute value of that V sub Q of T. So if you did that, you get another point. And then if you actually punched it in correctly and evaluated it correctly and got 106.108 or 109, then you actually get the full 3 points. All right, for part D. For part D, you get 1 point for knowing that you need to use this integral. So we see that integral right here, that gets you 1 point. Okay. Then we also know what the answer to that is from part B. And then you get 1 point for getting the position of Q, which means that you have to establish that you go with our Q at 0 and then integrate from 0 to 2.8. And we know that's going to end up being this negative 90 plus this, so that we get our answer there ends up being this time of 2.8, where they are this 5.188 meters apart, is what you end up getting for your final answer there. Okay, so because you're taking the difference between this. Here's the x of p at 2.8, here's the x of q at 2.8. All right, score that one out of 9, and let's move on to question number 3. So question number 3, you get 1 point for identifying that you must break this integral up into these two separate integrals. You must go from -6 to -2, and then add to that from -2 to 5. Knowing you have to break it up like that gets you 1 point. If you actually correctly calculate the integral from -2 to 5, so that would be this one right here. So if you correctly calculate that one to get this 2 plus this 9 minus 9 pi over 4, that gets you, having that answer, that gets you your second point. And then if you actually combine everything correctly and get to this answer, you could have left it like that or write it like this, you get your third point. Couple different ways to express B. It's one thing that was a pain about this, is there too many things could be done a couple different ways. But you get your fundamental theorem of calculus gets you 1 point, which in this way, that's essentially going from this step here to this step here, to knowing essentially that the integral from 3 to 5 of f prime of x is going to be f of 5 minus f of 3. That gets you 1 point right there. Or if you did it this way, it would be going from this step here, which is listed again here, straight to this step here, getting antiderivatives of each of these and knowing to evaluate from 3 to 5. So I guess actually you would have to, yeah, I think that would probably get it for you right there. Then if you actually substitute incorrectly and evaluate and get this for your answer, and you could have left it as that, that would have been okay, but that also works. You get your second point. Part C, we're looking for an absolute maximum on a closed interval with a continuous function. Perfect example for when we need to use the candidates test. So first we have to identify the relationship between g prime being equal to f of x. Somewhere that has to be indicated. It can be in the explanation, can be anywhere. We need to see that listed out somewhere. If it's not, you lose a point. Okay? Then if you actually look for where that's equal to 0, you should identify x equal to -1 as a candidate. Now you should also identify x equal to 1/2 and also 5, but the key is that you got the one, you get -1. The other two, we're not going to worry about them. Your answer with your justification, here's your justification. You check the value at each endpoint, and you check the value at each critical point, and the biggest one is this one. Therefore, that's your absolute maximum. And then going to D, D was just worth 1 point. It gave you this expression. You just had to interpret these values from the chart. Know that when x goes to 1, you can just substitute 1 into these and get the correct values when you substitute 1 in. Very straightforward. 1 point for getting it evaluated to have this be your answer. If you wanted to, you could multiply the top and bottom by 4 just to get rid of the denominator and call it 16 over 4 minus pi. That's fine, but that gets you your full credit. So score it out of 9, score the whole thing out of 27, and then go ahead and take a picture and turn it in. And we will have a Zoom session tomorrow if you have questions. So we'll talk about that tomorrow. I hope you're doing well.